Chapter 2.6, Algebraic Proofs. We're going to start with algebraic proofs because you've been solving algebraic equations for a couple of years now. And it is a form of proof. You don't usually have to write down every step you do, and you don't usually have to write down the justification for it. But we're going to do that in this section here. And as I've said before, solving algebra problems is a form of argument. That's why we're learning arguments right now. These properties you've already had. Addition property of equality, if you add the same thing to an equation, it's still equal. Subtraction, if you subtract the same thing from both sides of an equation, it's still equal. The same for multiplication and division. Reflexive property of equality tells us that something equals itself. So A equals A, measure of angle A equals the measure of angle A. Symmetric, if A equals B, then B equals A. Transitive, if A equals B and B equals C, then A equals C. Substitution is where if you have, let's say, 2x plus 3x, and we know that's equal to 5x, we can substitute 5x for that 2x plus 3x. Distributive property, A times the quantity B plus C equals AB plus AC. We're going to justify each step we take when solving the following equation. 2 times the quantity 5 minus 3a minus 4 times the quantity a plus 7 equals 92. We're going to show every step and we're going to justify every step. So the first step we're going to take is using the distributive property. 2 times 5 is 10 minus 6a minus 4a minus 28 equals 92. And that's the distributive property. Next, we'll combine like terms. So 10 minus 28 is negative 18. Negative 6a minus 4a is negative 10a equals 92. And that was by substitution. The next step we would take to solve this is to add 18 to both sides. So negative 18 minus 10a plus 18 equals 92 plus 18. And yes, you must show this step in that manner. And that's the addition property. Combining like terms again, we have negative 10a equals 110. Substitution. Next, we divide both sides by negative 10. And that's the division property. And finally, we have that a equals negative 11, and that was by substitution. Solving the next equation, the first step we would use is the distributive property. So negative 3a minus 9 plus 15 minus 5a equals negative 50. Distributive property. Next, we combine like terms. Negative 8a plus 6 equals negative 50. Substitution. Subtract 6 from both sides. Subtraction. Property. Negative 8a equals negative 56. Substitution. Divide both sides by negative 8. And then a equals 7. For the next one, it gives us that the distance d is d equals 20t plus 15, so that would be our given. Excuse me, 20t plus 5. d equals 20t plus 5. And we want to prove that if we solve for t, that t would equal d minus 5 divided by 20. So we're going to do a 2-column proof. The first column would be the statement. The second column would be the reason. Our first statement will always be the given. To isolate t by itself, we would subtract 5 from both sides to start with. Combining like terms, we would have d minus 5 equals 20t. Next, we would want to divide both sides by 20. So we would have d minus 5 divided by 20 equals t. But we were asked to prove that t equals d minus 5 divided by 20, so we need to flip it around the equal sign. And that is by the symmetric property. So we're given that the area of the trapezoid is A equals 1/2 times the quantity B1 plus B2 times H, and we want to isolate H by itself. So the first step would be the The first step would be using the multiplication property of equality. You notice we don't have any substitution here, so we're going to actually do it all the way through. Looking at the actual thing that we're doing is we're multiplying both sides by 2 so we can get rid of the 1/2, which would leave us with 2a equals base 1 plus base 2 times h. And that is answer A. As we get into the more difficult proofs, a lot of times we won't show every single step. If we say multiplication property of equality, we will have actually performed the multiplication. The same with the division property of equality. So here we're given that angle A is congruent to angle B. The measure of angle B equals 2 times the measure of angle C. And measure of angle C equals 45 degrees. Then the measure of angle A equals 90. So our hypothesis is usually our given, and the words that follow then, our conclusion, is what we're trying to prove. So again, we're going to do a 2-column proof. In this class, we're only doing 2-column proofs, so statement and reason. Number 1 will always be the given. Measure of angle, angle A is congruent to angle B. The measure of angle B equals 2 times the measure of angle C. And the measure of angle C equals 45 degrees. And that's all given. So first of all, to start to use the measures, we have to take the first statement that angle A is congruent to angle B and make it into an equality. So the measure of angle A equals the measure of angle B. And that's by the definition of congruence. And we can abbreviate and use symbols. So if we want to talk about the definition of congruence, we can just use the congruent sign. Now I still want to prove that the measure of angle A is equal to something, so I want to keep this measure of angle A, but I can substitute the measure of angle B with 2 times the measure of angle C. So the measure of angle A equals 2 times the measure of angle C, and I could either use the transitive property, the measure of angle A equals the measure of angle B, the measure of angle B equals 2 times the measure of angle C, then the measure of angle A equals the measure of angle B, so transitive. Or some people might use substitution. I would accept that also. Now again, we have measure of angle A equals 2 times the measure of angle C, and the measure of angle C equals 45 degrees. So we can substitute or use the transitive again. The measure of angle A equals 2 times 45 degrees. So I take it back. We're using substitution. We're going to take this measure of angle C and this 45 degrees. So we're substituting stuff we have in step 1 into step 3, and that gives us step 4. So now we have the measure of angle A equals 90 degrees, and that's by substitution. In this proof, we're given that AB is congruent to CD, CD is congruent to RS, and that AB equals 12. And we want to prove that RS equals 12. So our first step was to list the given, but this time we only list 2 of the given, the 2 that we're going to use for the first or the next step. So if AB equals CD and CD equals, if AB is congruent to CD and CD is congruent to RS, then we have that AB is congruent to RS by the transitive property. Notice in this proof also that we used our third given down here in step 4 right before we used substitution again, right when we needed it. In this class, I don't care if you use all your given in the first statement or if you break it up and put it in the proof as you need it. So in this last proof, we're given that the measure of angle ABC plus a measure of angle CBD equals 180 degrees. The measure of angle ABC equals 2x plus 10, and the measure of CBD equals x plus 50. and we want to prove that x equals 40. So our two-column proof, statement, reason. Number 1 will list the given. Well, CBD equals 180. The measure of angle ABC equals 2x plus 10. The measure of angle CBD equals x plus 50. And that was given. Now if I take the first statement here, measure of ABC plus measure of angle CBD equals 180, and I plug in the information we have here, I'll have that 2x plus 10, which is the measure of angle ABC, plus x plus 50 equals 180. And that is substitution. Next, I'll combine like terms. Which is 3x plus 60 equals 180. Again, substitution. Then I'll subtract 60 from both sides. Which is the subtraction property. So I have 3x equals 120. Substitution. Divide both sides by 3. Which is the division property. And I end up with x equals 40, which is what I wanted to prove. I wanted to prove that x equals 40. And that was substitution. And that concludes lesson 4, chapter 2-6.